What's up guys? This is Engineer Jack. So, this is our first topic sa structural theory. Pag-usapan natin dito yung introduction to structural engineering, functionality, the analysis and design process, classification of structures, building materials, and types of supports, support reactions, support connections. So, let us first define a structure. A structure refers to a system of connected parts used to support a load. So basically, we have two types of structure. We have vertical structures and horizontal structures. Example of vertical structures, we have buildings and towers. And example of horizontal structures like bridges and roads. So we design a structure to serve a specified function for public use. Or ibig sabihin ng function, para saan ba yung structure natin or yung purpose niya. Or another term natin for function is occupancy. So dito sa Pilipinas, we have the National Structural Code of the Philippines as our local code and ginagamit natin ito when we designing vertical structures. So in section 103, we have classification of structures and meron table 103-1 occupancy category. So we have 5 categories of occupancy. We have essential facilities, hazardous facilities, special occupancy structures, standard occupancy structures, and miscellaneous structures. So example ng essential facilities, we have occupancies having surgery and emergency treatment areas, fire and police stations, structures and equipments in communication centers, and other facilities required for emergency response, public school buildings, hospitals, designated evacuation centers, power and communication transmission lines. And we have also another example, hazardous facilities. We have occupancies and structures housing or supporting toxic or explosive chemicals or substances. And another example of hazardous facility, we have non-building structures storing, supporting, or containing quantities of toxic or explosive substances. Another category of occupancy, we have special occupancy structures. Example niyan is educational buildings such as museums, libraries, auditorium with a capacity of 300 or more occupants. Buildings with an assembly room with an occupant capacity of 1,000 or more. Buildings used for college or adult education with a capacity of 500 or more occupants, churches, mosques, and other religion facilities, or structures with a capacity of 5,000 or more persons. So as you can see, yung special occupancy structures, nakafocus siya more on maraming population. Another category of occupancy, we have standard occupancy structures. All structures housing or occupancies or having functions not listed in category 1, 2, or and category 5. And last category, we have miscellaneous structures. Example is private garage, carports, sheds, and fences over 1.5 meter high. Pwede nyo yan guys i-check sa code, nakalagay naman dun yan. So these are only some occupancies. We have building materials. Ito yung mga available sa Pilipinas na common na ginagamit natin in constructing a structure. So we have concrete, steel, and wood. Classification of structures. Structures can be classified into 5 basic categories depending on the type of primary stresses that may be developed in their members under the major design loads. That's why we are studying strength of materials, we are solving the stresses, mga ganun. So number 1 is tension structures. The members of tension structures are subjected to pure tension under the action of external loads. Example ng tension structures, we have cables. Cables are usually flexible and carry their load in tension. Another term for cables is steel wires. So example niyan, this is a suspension bridge na gumagamit ng cables. Another type of tension structures, we have tie rods. Structural members subjected to a tensile force are often referred to as tie rods or bracing struts. So, example niyan, ito yung tinatawag na tie rods. Ang dinadala lang niya na load is pure tension. Number 2 is compression members. Compression structures develop mainly compressive stresses under the action of external loads. Example niyan is columns. Members that are generally vertical and resist axial compressive loads are referred to as columns. So, ito yung mga vertical members ng frames natin and nire-resist nila is axial loads. So, example niyan, these are 3D frame. As you can see, yung mga kulay pula, these are columns. And itong malapad na wall, ang tawag dyan is shear wall. So, load-bearing wall din siya, kaya pwede din siyang tawaging column. Take note, when a straight members is subjected to lateral loads and or moments in addition to axial loads, it is called a beam column. Ibig sabihin, kung yung column natin, hindi lang axial load yung dinadala niya, meron ding moment, so ang tawag sa kanya is a beam column. We have also another type of compression structures. We have arcs. An arc is a curved structure that is usually made of stone, brick, concrete, or more recently steel. Its purpose is to support or strengthen a building. So for example, this is an arc. As you can see, ginamit siya sa bridge. And another type of arc, as you can see, paper. Pag naglagay tayo ng for example, a beam, naglagay tayo ng load. Pero kung lagay natin ng arc, medyo mababawasan yung bending niya. Tapos yung dadali ng arc natin is more on compressive stresses. The arc achieves its strength in compression since it has a reverse curvature to that of the cable. Number 3, we have trusses. Trusses are composed of straight members connected at their ends by hinge connections to form a stable configuration. And loads are applied only at the joints. So, as you can see dito sa picture, yung loads niya lang, pwede lang natin i-apply sa connections or sa joints. Wala tayong load sa member mismo. That's our rule in our truss. And usually, yung dinadala lang ng load ng trusses or the members of the truss are usually axial loads. Walang bending, walang shear, more on axial lang. When a truss is subjected to loads, its members either elongate or shorten. Thus, the members of an ideal truss are always either in uniform tension or in uniform compression. Trusses are most commonly used in bridges, roofs, and towers. Example ng planking trusses or 2D truss. So, may mga tawag sa kanya, no? So, for example, may king post, queen post, fink truss, how truss, mga ganun. These are 2D trusses. Space trusses, just like this picture, space truss or 3D trusses. Ginagamit natin yung truss, pwedeng sa bridge, pwedeng sa buildings, sa roofs, mga ganun. Another example, this is a electrical supporting system. Another example, as you can see in the left picture, this tower crane. Ang gamit niya is a truss din. Yung right picture, this is the Eiffel Tower. Number 4, we have also shear structures. Shear structures, such as reinforced concrete shear walls, are used in multi-story buildings to reduce the lateral movements due to wind loads and earthquake excitations or earthquake loads. Itong malapad na wall, ito yung mismong shear wall. And yung purpose niyan is to resist lateral loads. Number 5 is bending structures. Bending structures develop mainly bending stresses under the action of external loads. In some structures, shear stress associated with the changes in bending moments may also be significant and should be considered in their designs. Actually, palaging magkasama yan. Pag may bending tayo sa horizontal structures natin, palaging yung may kasama na shear. So, example ng bending structures, we have beams. Beams are usually straight horizontal members used primarily to carry vertical loads. These are example of beams. As you can see sa picture, these are steel structures or yung material na ginamit is a steel. We have also another bending structure, ang tawag frames. Frames are often used in buildings and are composed of beams and columns that are either pin or fixed connected used to resist lateral and gravity loads. Like trusses, frames extend in 2 or 3 dimensions. So, pwedeng 2D or pwedeng 3D. So, example niyan, ito nga, this is a 3D frame. And yung sabi nga kanina, yung frame is composed of beams and columns. So, yung mga vertical members these are columns. And yung mga horizontal, these are beams. Yung mga plate, ang tawag naman dyan is a slab. Then, ito, yung malapad na wall, that is shear wall. And yung sa baba, these are footings. Unlike trusses, which are subjected only joint loads, the external loads on frames may be applied on members as well as on the joints. So, as you can see, yung distributed load, yung W2 and W1, these are distributed loads or gravity loads. And we have also concentrated loads na P1 and P2, nakalocate sa joints ng frame. And these are horizontal loads or lateral loads. Next, pag-usapan natin yung analysis and design process. Structural engineering is the science and the art of planning, designing, and constructing safe and economical structures that will serve their intended purposes. And the function of structural analysis is to predict the performance of the proposed structure. So, because of loads, ano ba mangyayari sa structure natin? So, kailangan natin i-analyze kung safe ba yung structure due to loads, mag-uniform ba siya, ano ba mangyayari? So, this is the flow flowchart showing of various phases of typical structural engineering project. So we have planning phase. After nyan is preliminary structural design. Then we will estimate the loads. Then doon na papasok yung subject natin, which is the structural analysis. And after nyan, are the safety and serviceability requirements satisfied? If yes, we will construct na. Kaya diretso tayo sa construction phase. But if no, i-revise natin yung structural design tapos babalik tayo sa estimation of loads. Then mag-a-analyze ulit tayo. Check naman natin yung safety and serviceability. Kaya ang tawag dito guys sa design process is iterative kasi ulit-ulit. Unahin natin guys yung planning phase. The planning phase usually involves the following. Una, structural factors. So the functional requirements of the proposed structure, pag-usapan natin yan. And number 2, the general layout and dimensions of the structure. Consideration of possible structures that may be feasible and types of materials to be used. So yan yung pag-uusapan natin sa planning phase, yung structural factor. Siyempre, pag-uusapan din natin yung non-structural factor. Number 1 is aesthetics or yung beautification. Number 2, the environmental impact of the structure. And yung pangatlong i-consider natin sa planning phase is the economic factor. Yung structure natin dapat most economical. Pangalawa, yung preliminary structural design. In this phase, the sizes of the various members of the structural system are estimated based on approximate analysis, past experience, and code requirements. And these estimated member sizes are used in the next phase to estimate the weight of the structure. Yung mag-estimate tayo dito ng, for example, yung dimension ng structure natin, tapos magbe-base tayo sa codes, for example. And for example, sabi ng code, dapat daw yung minimum dimension ng column, 300 millimeters. Yun yung i-consider natin as preliminary structural design or the estimate of the size of the members. Then after nun, the preliminary structural design, we will estimate the loads. So estimation of loads involves the determination of all the loads that can be expected to act on the structure. E dapat i-design natin siya, i-consider natin lahat ng loads na possible na mag-act sa structure. And after nun, papasok na yung structural analysis or yung itong subject na to. The estimated loads are used to carry out the analysis of the structure in order to determine the stresses or stress resultants in the members and deflections at various points of the structure. So after natin malaman yung stresses, resultants, and deflections, dun na natin malalaman kung ano bang best structure na gagamitin natin. May iba-iba tayong types of structures natin. Meron tayong tension, compression structure, bending structures, mga ganun. Kaya kailangan natin ng structural analysis. Then after nun, dito na papasok yung safety and serviceability checks or yung safety, yung strength ng material. The results of this analysis are used to determine whether or not the structure satisfies the safety and serviceability requirements of the design codes na ginagamit nga natin sa Pilipinas is the NCP. If these requirements are satisfied, then the construction phase begins. And if not, syempre, revise is structural design. So if the requirements are not satisfied nga, then the member sizes are revised or babaguhin natin yung member size or the materials, and phase 3 to phase 5 are repeated until all the safety and serviceability requirements are satisfied. Sabi ko nga kanina, this is an iterative process, paulit-ulit. Pag-usapan naman natin yung types of supports. These are types of supports. So we have the table here, merong type of connection, idealized symbol, these are the reaction, and number of unknowns. So yung number 1, this is a light cable. Ito yung actual structure niya. This is the idealized symbol. Tapos yung reaction niya, isa lang, perpendicular to the member. And one unknown, the reaction is a force that acts in the direction of the cable or link. As you can see, yung force niya is tension. Kasi yung dinadala ng cables lang, always tension. Number 2 type of connection, we have rollers. So these are the typical actual structure niya. And idealized symbol niya, ganito. Kaya pa nag-solve tayo ng mga free body diagram sa mechanics, ay itong ginagamit natin na idealized symbol. Then yung reaction niya, isa din. One unknown, the reaction is a force that acts perpendicular to the surface at a point of contact. So, tandaan nyo lang guys, always pag rollers, tapos yung surface niya, yung reaction doon always perpendicular. Yung idealized symbol or tinatawag natin na analytical model is a simplified representation or an ideal of a real structure for the purpose of analysis. Then, another types of supports, we have smooth contacting surface. So, ito yung real structure niya. This is the idealized symbol and ito yung reaction. Yung number of unknowns, one unknown din. The reaction is as a force that acts perpendicular to the surface at a point of contact. Number 4 is smooth pin connected collar. This is the actual structure. for this, the idealized symbol, ito yung reaction din. When unknown, the reaction is a force that acts perpendicular to the surface at a point of contact. And we have also number 5, smooth pin or hinge. Ito yung idealized symbol niya. Then yung reactions niya, meron tayong 2 unknowns na. The reactions are 2 force components. So meron tayong Fy and Fx. Yung Fy, a force along the y-axis or the vertical axis. Then yung Fx, for horizontal force along the x-axis. Number 6, we have also a slider. Ito yung ano niya, real structure niya. Idealized symbol. This is the reactions. Meron dalawa. We have 2 unknowns. The reactions are a force and the moment. And number 7, na pinaka-last na types of support natin, we have fixed support. Fixed support, ito yung idealized symbol niya. And we have 3 unknowns. We have 3 reactions. The reactions are the moments and the 2 force components. So meron tayong moment na reaction and we have Fy and Fx. We have also support connections. Structural members are joined together in various ways. The 3 types of joints most often specified are the pin connection, the roller support, and the fixed joint or fixed support. Example ng typical pin-supported connection, for example, sa steel structures natin, ito yung I-beam and this the column. Pareho, steel yung ginamit. So yung connection nila, this bolted, pero pin to kasi yung both ends ng top and bottom ng beam, pwede pa mag-rotate. Hindi niya malilipat yung moment from beam to column. Kaya, zero yung moment din dito. Ito yung example ng typical fixed supported connection. As you can see, yung top and bottom, nilagyan ng another support, naglagay ng weld. As you can see, may angle bar, tapos bolted din. Pag ganyan na guys ang nangyari, tapos may stiffeners pa, hindi na mag-rotate yung beam natin from top or bottom. Magkakaroon tayo ng moment na yung moment natin from beam, malilipat na to column. Kaya, ang tawag sa kanya is fixed supported connection. Ito yung tawag din sa typical roller supported connection. As you can see, one-sided lang yung support, yung vertical lang, walang magre-resist sa horizontal. Para siyang sliding lang, no? Parang nakapatong lang yung beam to column. Kaya, ang tawag sa kanya is roller support. Ito naman yung tawag sa fixed supported connection. As you can see, this monolithic construction kasi sabay ang buhos ng beam and column. So, pag ganyan, fixed supported. And thank you very much. Next topic natin guys, pag-usapan natin yung loads of structures. And thank you.